Hello aspirants, welcome to Testbook Supercoaching. Today we're going to talk about the eigenvectors and eigenvalues of position operator and momentum operator in both position basis and momentum basis. So first of all, let's talk about the eigenvectors and eigenvalues of position operator. Eigenvectors and eigenvalues of position operator, that is R vector cap 3D. Of course, we are talking about 3 dimension. So we know this thing in bracket notation. हम लोगों ने bracket notation पढ़ा है और हम लोगों ने देखा है कि R cap operates on some vector ket R and it provides you the eigenvalue R into ket R. This is a vector operator जो ये देता है. Now, so R, suppose I can just write it as like R naught, this is R naught, this is R naught. So I can write R naught is the eigenvalue of R vector cap with eigenvector R naught vector ket with eigenvector this. Now, since the spectrum, the eigenvalue spectrum of R vector operator is continuous, therefore its eigenvectors are not normalizable, therefore its eigenvectors are not normalizable, though they satisfy closure property. Though they satisfy closure property and form a continuous basis of Hilbert space. Therefore, you can just write down R dashed del of R minus R dashed, that is also equals to del of R dashed minus R. And what do you mean by the closure property? Integration R dq R dq bar should be equals to I cap over all space. That thing has to be satisfied. Now, R vector in position space, get R vector not vector in position space representation that is in the eigenvector of the position operator in terms of it should look like R into R के साथ R नॉट का इनर प्रोडक्ट, जो हमें पता है R के साथ साई के इनर प्रोडक्ट करके तुम साई ऑफ R लिखते हो, काइंड ऑफ वैसी वाली चीज है यहाँ पे करना है तुम्हें. But they satisfy the orthonormality property. We have just seen that two eigenvectors of the position operator always satisfy this relation, so it has to be del of. What can you write? R naught को लिख सकते हो del of R vector minus R naught, which can also be written as del of R naught minus R vector. मोमेंटम रिप्रेजेंटेशन में क्या होगा? R naught vector get in momentum representation. You can just write it down as P R naught. बहुत बार मैंने तुम लोगों को प्रूव करके दिखाया है, वैसे भी क्लास में प्रूव करके दिखाया है और ऐसे शॉर्ट वीडियोस में प्रूव करके दिखाया कि पोजीशन मोमेंटम रिप्रेजेंटेशन कैसे एक दूसरे के साथ रिलेटेड होता है. तुम लोग अगर प्रीवियस लेक्चर देखोगे तो you can just see by yourself that we have related these two things by Fourier transformation, and from which you know this formula that RP का फॉर्मूला ये आता है, PR का फॉर्मूला ये आता है. गुड. तो हमें क्या चाहिए? हमें चाहिए PR नॉट का इनर प्रोडक्ट, सो इट शुड बी 1 divided by 2 pi h cut to the power of 3 by 2 e to the power of negative I P dot R naught by h naught. बट ऑफ कोर्स यहाँ पे ये वाला तो है ना, P cap R naught divided by h. So this is the basically in momentum representation. Okay, momentum representation में तो momentum operator नहीं होता, simply ये होता है. तो ये momentum representation में it should be a function of P only. R naught is just a constant. So yes, it's a function of P. तो simply P के ऊपर वेक्टर नहीं जाएगा, मतलब ऑपरेटर नहीं जाएगा. P will not be represented as an operator. P will not be represented as an operator. It will just be taken into consideration as a vector quantity. Right? मैं एक बार फिर से देख लेता हूँ कि यहाँ पे उसको ऑपरेटर का फॉर्म में लिखा गया था या नहीं. No, it was just like a vector. It was just like a vector, not an operator. It's a function of that thing. Good. Done. So this thing is done. Now we can talk about the eigenvalues and eigenvectors of momentum operator in the same way. We can just talk about the eigenvalues and eigenvectors of the momentum operator in the same way. Just let me write it down. Eigenvalues and eigenvectors of momentum operator P cap. P vector cap because I'm talking about 3D. So just write it down in this way. P vector operator should operate on state P naught having momentum P, should give you P naught, state should be P. Right. So P naught is the eigenvalue of P with eigenvector P naught. So P naught is the eigenvalue of P with eigenvector P naught, ket of P naught. Now सेम चीज यहां पे भी हमें लिखना है. Now since the spectrum of momentum operator P is continuous, spectrum means eigenvalue spectrum, I should rather mention the eigenvalue spectrum of P vector operator is continuous. Therefore, its eigenvectors are not normalizable although they satisfy the closure property and form a complete orthonormal basis and form a continuous basis of the Hilbert space. Although they satisfy closure property and form a basis of the Hilbert space. Form a basis. जो तो करना ही, कोई भी हार्मिशियन ऑपरेटर का आइगनवेक्टर हिल्बर्ट स्पेस का बेसिस बनाता है. मोमेंटम ऑपरेटर इज अ हार्मिशियन ऑपरेटर, पोजीशन ऑपरेटर इज अ हार्मिशियन ऑपरेटर. So their eigenvectors has to form a basis of the Hilbert space. Basis of Hilbert space. Now I can just represent it. P dashed P dashed, दो आइगन वेक्टर्स के बीच का जो इनर प्रोडक्ट होता है वो क्या होता है? डेल ऑफ P माइनस P डैश्ड. तो डेल ऑफ P डैश्ड माइनस P दोनों सेम चीजें हैं, तो घबराओ मत. कौन सा आगे लिखा हुआ है, कौन सा पीछे लिखा हुआ है, इस बारे में बिल्कुल टेंशन मत करना. क्लोजर प्रॉपर्टी इज P d cube P all space, all momentum space should be equals to I. जैसे यहां पे हमने dr all space में I लिखा था. डन. ठीक है. ये होने के बाद I can write P cap in position representation. That should be equals to R vector के साथ P cap का inner product और P naught in position representation, which is an eigenvector. ये position representation में कैसे दिखाएगा? See, we know P R naught is this. तो इसका पोजीशन के साथ मोमेंटम का जो तुम्हारा इनर प्रोडक्ट होता है उसको हम लिख सकते हैं 1 डिवाइडेड बाई 3D में 2 पाई h कट टू द पावर ऑफ 3/2. बहुत बार प्रूव करके दिखाया गया है. फूरियर ट्रांसफॉर्मेशन से आता है ये फॉर्मूला e टू द पावर ऑफ I इनटू P नॉट डॉट R. ये कांस्टेंट है, ये यहां पे एज अ फंक्शन बाई h कट. और अगर तुमसे पूछा जाए कि P नॉट इन मोमेंटम रिप्रेजेंटेशन, मतलब मोमेंटम आइगन बेसिस में, इन मोमेंटम representation कैसा होगा वो? It should be written as P के साथ P नॉट, जो तुम्हारा आ जाएगा डेल ऑफ P माइनस P नॉट, डेल ऑफ P naught minus P, same cheese, doesn't alter anything. You can write the function as like this or the function is like this. So it's basically a function of P, it's basically a function of R. It's a function of R, it's a function of P, right? Function of R with eigenvalue P naught. This is function of R with eigenvalue. Function of, it's a function of P with eigenvalue P naught. You can just do the representation as this way. If you want, you can just write it as function of or rather it's better if you don't write it in that way. Just name it like this. Chalo, I hope that was helpful. Thank you very much. And if you have any doubt, please let us know. We will clear your doubt in the comment sections. So that was the eigenvalues and eigenvectors of position and momentum operator, both in your position basis and in your momentum basis. Thank you.